Welcome you all to this special webinar on Cisco VPN technologies. My name is Debashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions. And today we'll discuss about the Cisco's VPN virtual private network, about the remote access VPN solutions, as well as the site-to-site VPN. So what is a VPN and what are the types of VPN, how to configure it? So let's begin. So we'll cover the Cisco VPN technologies here and we'll focus on site-to-site and remote access VPNs and their configurations, purposes, and the benefits. So what is a VPN? What is a site-to-site VPN? What is a remote access VPN? First of all, VPN is a virtual private network that is used to connect between remote locations, like say location A, B, C, D, different locations are there, and you want to connect all these locations together remotely. So in that case, you have different options, like you can go for lease line, you can go for MPLS, multi-protocol level switching, you can go for say the mobile networking. But can you set up mobile towers, say thousands of mobile towers? You cannot, because it is very costly. So in that case, you need to have some cost effective measures to connect different locations. There can be two or more locations. Now VPN by default, it is not secure. You have to incorporate some security protocols, some encryption protocols to make it secure. So what is the definition and purpose of VPN? Say the site-to-site VPN connects entire network securely over the internet, and it allows multiple sites to be linked. So in case of VPN, you have different type of VPN, like the site-to-site. Like you are connecting different locations together, two or more locations all over the world. That is the site-to-site VPN, and it is the most common form of VPN that you can configure. Now we can enable secure data exchange between them as if they are on the same local network. And this technology is often used by organizations with multiple office locations all over the world. And say one is the central office or the hub, and other are the spokes. It's a hub and spoke topology, you can say, or you can have two offices connected together also. So there are different topologies you can use and different VPN networks you can use. What is the configuration overview of this VPN? How to configure it? So setting up a site-to-site VPN involves configuring VPN devices at each end. So at each location, you have to configure the individual routers. You have to configure the individual devices there, because everywhere there is a VPN server. So who is the VPN server? Where to whom you are connecting? That is the server, and you are the client. So it is relative. That say now I'm connecting to server A. So I'm the client. That is say B, server B, and the server is the VPN server. Now, when the server A will dial, then that will be the client. So it is relative. And it includes defining VPN peers like the clients, selecting encryption methods or the protocols, and setting up the routing protocols as well, because you have to do the routing also. It is not that only you are configuring the encryption protocols, but routing protocols like RIP, EIGRP, OSPF, BGP, all this will be supported over that VPN protocol. Key protocols involved for security are IPsec, Internet Protocol Security, GRE, Generic Routing Encapsulation, and IKE Exchange, also Internet Key Exchange. So that is where you configure the pre-shared keys between the routers. So all these things are incorporated in the security framework of the VPN, and it ensures data confidentiality and integrity. Now, what are the use cases and benefits of VPN? Now, the site-to-site VPNs are ideal for connecting branch offices. Now, where you are having different branch offices located all over the world, in that case, the site-to-site VPN will be deployed, and it will enable secure communication for VoIP services, voice over IP, intranet applications, and shared resources. So all these are fine in case of this site-to-site VPN. And organizations benefit from the cost efficiency of utilizing the internet to connect their network securely, and they avoid expensive lease lines. So lease lines are expensive, as you know, because lease circuits are dedicated circuits. So it is always on 365 days, 24 into 7 on, and it is never disconnected. So you have to pay for the lease circuits even if you are not using it. See, I am not using it for today, but I have to pay for it 24 hours basis. So this is definitely expensive. It is a dedicated private connection, just like the VPN. So in that case of VPN, it is giving you a virtual channel, a virtual path that is actually acting like your private network. That is why it is virtual, because generally it is a public line, but you are using the VPN tunnel as your private network. So it is cost effective than the lease line, and it is secure. It is more secure than the lease line. So VPN is the best solution that you can get. Now, what is about the remote access VPN? So we have talked about the side to side VPN, and now let's come to the remote access VPN part. The remote access VPN means that you are dialing to the VPN server, say from the mobile location, say from laptop, or from any VPN client, say from your smartphone. You are dialing to the VPN server. That is, remotely you are accessing the VPN. Now, remote access VPN allow individual users to connect securely to a remote network over the internet. So you are dialing to the VPN. And this technology ensures that remote employees have access to necessary resources while maintaining security. And key features include encryption, authentication, all these things, and ease of use through client software. What does it mean? It means that you have the client software, VPN client, installed on your smartphone. That is not the server, but that is a client PC. Like, you can configure it, you can install it on your, say, desktop or laptop also, say Cisco AnyConnect VPN, like that. And there are many VPN solutions, VPN third-party solutions that you can download and install, and you can use to connect to any VPN server with that application. That is a remote access. Now, what is the client configuration steps? To configure a remote access VPN client, users must first download and install the appropriate client software on the device. Then the key steps include inputting server address, then authentication credential, and selecting desired encryption protocol. So if you are going to connect to any server, you have to provide the details, like what are the server name and the IP address, authentication credential. Then you are using, say, the CHAP or PAP protocol. So what are the authentication protocols you are using? Then the desired encryption, like the IPsec, GREIK, all these things. And you have to test the connection to ensure reliability, that yes, the connection is stable. Otherwise, you cannot connect it. What are the security considerations for VPN? Now, security for remote access VPN is very critical and paramount to network security, since the remote connections can expose the network. So, definitely, your network should be very secure. Then, key considerations include implementing strong authentication methods or authentication passwords, using robust encryption standards, such as you can go for the AES encryption, advanced encryption standard. That is a very advanced form of encryption protocol, and regularly updating softwares to protect against vulnerabilities and attacks. Organizations should also monitor access logs also. The log monitoring should be implemented in the VPN. So you can go for different encryption protocols, algorithms like the SHA algorithm, MD5, AES. So these are the RSA. RSA is a very secure algorithm. So you can go for these algorithms for the VPN, because encryption is very much considered in case of VPN. Now we can conclude that both side-to-side and remote access VPNs provide very effective solution for ensuring secure communication. And when properly implemented, they will definitely enhance the security and improve productivity, and definitely they will enable the flexible work environment. So definitely in case of VPN, these two solutions go hand in hand, and one is for connecting different sites, and then other is for dialing to the VPN server remotely. Say VPN server is at the office and you are dialing it from the home and you are configuring it. That is a remote access VPN you can also use. Or you are in a remote location and you are dialing to the VPN server to your corporate headquarters. For that, also this remote access VPN is used. So that is about the theory part about these two VPN technologies that we use. And let's configure it now in the Cisco packet tracer. Now here you can see there are different routers there, and I will show you a diagram here I will make, and I will explain this diagram and configure it. So you can configure it in a 1841 routers here. You cannot configure it on the PT router because the PT router doesn't support the VPN tunnel. So let's take to 1841 routers, and you can configure it using this say crosscable for now, or you can go for the serial interface. Then you have to attach the serial interface here, but for now, let's say for test purpose, I'm connecting it to the fast ethernet. That is the physical line. Always remember that the data flow is happening through this physical connection. Either it can be fast ethernet or it can be serial. So if you're connecting two or more routers, that is a physical media, like the IP protocol. So the IP protocol, the TCP/IP protocol is always there on the physical media, and the data is flowing through this physical interface, not through the tunnel. So there must be a tunnel between these two routers, as we know, and that is the VPN tunnel. And there would be a tunnel interface on both the routers. Now, tunnel interface is definitely logical. So you cannot say that the data is flowing through the tunnel interface. Tunnel is for only for the encryption, authentication, data integrity, all these things. So let's start by configuring the fast Ethernet port first. No shut, and then give the IP address, say 11001. Because I'm giving the public IP, because in VPN you should have the public IP. If you want the full security and encryption, you should take the live IP, public IP from the ISP. You can configure it with the private IP definitely, but that private IP would be in the tunnel interface, not in the physical. And then go to the router one. Now let's configure the tunnel interface now. Interface tunnel, and if you give the mark, it is not giving you. So let's say you are giving, let me see, it is not giving you the range. Anyway, you give the tunnel 0 and you can see that the tunnel 0 is up because it's a logical interface. Now it is already up, like the loopback interface you have in the OSPF. First of all, you give the IP address. So you are giving the private IP like 192.168.0.1, and then the tunnel mode GRE space IP. So what does it mean? It means that it is using the IP protocol number GRE. You are incorporating GRE here, generic routing encapsulation. This is the encapsulation protocol, that is you are incorporating in the VPN. Now there are two choices. I've already told you, either IPsec you can implement in the VPN or the GRE. Now IPsec is a very high level protocol. It's a very advanced protocol, we know, but it's a complex also. So IPsec is used normally not only in site-to-site VPN, but you can use it in the DM VPN, that is dynamic multi-point VPN, when you are using a hub and spoke architecture, and without consulting the hub, the spokes can communicate directly with each other. In that case, also you can do. You can also use IPsec over the GRE. So these configurations are there in the CCNP level. It is a big configuration, but here, in case of say a basic CCNA level, you are using the GRE protocol. GRE doesn't give you a lot of security, but it definitely carries the routing protocols, and it gives you a lower level security and authenticity and data integrity, but not at that IPsec level. And GRE space IP means that is using the IP protocol 47 here. So here the port number is using that IP port. That is why it is GRE space IP. So on the router one also you give that. Tunnel mode GRE space IP. Or you are not, okay, let me go to the tunnel here. I haven't created tunnel. Okay, now first set the IP address. So it's 0.2. Here also tunnel mode GRE space IP. Now after this, you specify the tunnel source and the destination. Now the tunnel source, what will be the tunnel source? The packet tracer, you give the tunnel source as the interface name, not as the IP address. But in real router, and if you go for the advanced simulators like GRE, GNS3, or in the EVG simulator, there you will see that you give the IP address. But in the packet tracer, you give the tunnel source as the interface name. And which interface will you give? That is definitely the fast Ethernet, right? Because I've already told you that the GRE, the tunnel, is a logical one. So the data is passing through the physical interface, not through the logical one. So what is the source interface here? Definitely fast Ethernet 0 by 0. And what would be the tunnel destination? You see that it's IP address. It is accepting the IP address. For the destination, it doesn't take that name, it takes the IP address. That is the IP address of the physical fast Ethernet port of the other router, that is the router 1. And definitely that would be the 11002, because you can see here we have the 11001 here. So that would be 11002. If you make mistake here, and if you by mistake give the tunnel interface, the tunnel will never come up. Now, as soon as I give this, the tunnel should come up. Let's see. Yes. So you can see that the line protocol on interface tunnel 0 is up, means that the tunnel encryption is up. So data link layer connection is already established. Now, similarly, you go to the router 1 and you give tunnel source as again the fast Ethernet 0 by 0, because that is a physical interface you have here. And the tunnel destination will be this time the 11001. So you can see the tunnel has come up. So you can also check it out with show IP interface brief. You can see the tunnel 0 interface IP, and it is manual method status is up, protocol line protocol is also up. So there is a data link layer as well as a network layer connectivity is established. And then you can go for show interface tunnel 0. You can see the tunnel is up and line protocol is also up. It is connected, and you can see that is a tunnel protocol is GRE over IP. You can see all the configurations there, the tunnel source and destination, all these things you can see. And alternatively, you can also configure the routing protocol if you want. Then you can configure the routing protocol on both sides, either say any protocol, RIP, EIGRP, OSP, BGP, anything, and you'll see definitely they'll communicate because the GRE supposes protocol. Now, this is about the configuration, and in the GRE protocol, you can see that one thing is added in the GRE. In the GRE, with the IP header, you add an GRE header. That is the extra one. So in the IP header, if you have the source IP address as the IP address of the Ethernet port, physical Ethernet port like the 11001, with that, the GRE header 192.168.0.1 is added. And when the data is passing through the GRE tunnel, then the original, the source IP header, that is replaced by the GRE header, because the data is encapsulated. The GRE is encapsulated within the IP header. That is the outer header. GRE header is the outer one, and the IP header, it is in the inner one. So later, if you capture the packet on the Wireshark, you will see more better that the GRE header is added to the IP header. For now, we are not doing it that much, but yes, the knowledge you should have, at least for the CCNA as well as the CCNP exams, that there are two headers that is added to the VPN, the side-to-side VPN or any type of VPN, and the header is encapsulated in the IP header. So this is about the configuration, a very simple configuration as such about the GRE, because other protocol configurations, IPsec, DMVPN, IPsec over GRE, even if you can do the MPLS layer 3 VPN configuration, there is a very big one and a big complex configuration. You have to go for the VRFs, all these things are there. But in this basic level, in the CCNA 200301 level, you have this GRE tunnel configuration that is very important for your exams. Also, in case of the CCNP, NRC, and ENCORE papers, also you have these VPN tunnel configurations, and you can troubleshoot these configurations. Also, like if you have misconfigured some interfaces on any of the sites, then definitely the tunnels will not come up. So those misconfigurations also, I think you'll be able to rectify. So for now, I think that is it about the VPN solutions we have. And I have discussed with you about both the solutions, that is the side-to-side and the remote access VPN solution. That is one of the major parts of the VPN. These are the two major types of the VPN. And I think it was valuable for you, and you have gained an immense knowledge on the VPN technology now from this webinar. And it will be very helpful for you for your future studies on CCNA and the CCNP as well as CCI examinations. So I hope that you'll be able to incorporate this also in your enterprise networks, and you will make it very secure. So I thank you all for watching and joining this webinar once again. So that is about the VPN technology for now. I will come with some new topic next day. Till then, keep studying and bye.